In a different corner would be butene, specifically 2-butene, and the formula for this is C4H8, which seems to fit the same formula for a cycloalkane. However, we would not call this compound an alkane. We call this type of compound, a compound that contains a double bond, an alkene, hence the ending butene. So this is an alkane, and on the right we have an alkene. The ending "ene" means double bond. The formula for a branched alkene is actually the same as that for a cycloalkane, which is CnH2n. The most important takeaway for this is that saturated compounds have no double bonds and no triple bonds. An unsaturated compound has at least one single or double bond in that carbon chain. Although you don't need to know this for most general chem classes, the 2 in front of the 2-butene denotes that the double bond is on the second carbon. It is between the second carbon and the third carbon, and the 2 denotes that it is starting with the second carbon and then goes to the next, which would be the third carbon. When there are only single bonds present, we call that an alkane. When there is a double bond present, that is called an alkene. An alkyne is the name of a compound that is a hydrocarbon with a triple bond. Propane, we know that pro means 3 carbons, and ane means, well really prop means 3 carbons, and ane tells us that they are singly bonded together. Under this understanding, we can know that an alkane is going to be CnH2n plus 2 for the formula, if it's not cyclo. And since it doesn't say cyclopropane, we can follow the normal formula for an alkane. The formula will be C3, double 3 to 6, add 2, and it's 8. If you were to draw it, you connect all of your carbons using a single bond, complete the octet for each carbon, and that is where the hydrogens will go. Notice the difference in propane versus what I just drew, which is propene, that has a double bond and therefore loses 2 hydrogens. The suffix "ine" means that there's a triple bond, and the formula is changed once again to C3H4. We double 3 to 6 minus 2, and we get 4, which is in accordance to the formula for propyne. Alkanes are saturated, and alkenes and alkynes are unsaturated due to the double and triple bonds. The next video will cover what exactly functional groups are and the main functional groups that you can look for in molecules.